Today we're doing our energy stations, and you've got a chief challenge in front of you. I'm gonna give you about 3 minutes. The exit ticket is also on the sheet, but please do not do the exit ticket, okay? So if you would just take about 3 minutes and do your chief challenge. Today's lesson was an overall review of energy. The purpose is we're learning in science as we go to 3 dimensions that if a student only has experience in one area of that dimension, it doesn't necessarily cover their needs. They're sometimes still surprised by questions, other questions if it's out of a different area. They can't always take one principle from one area and apply it to the other. So it's really important that we give students an opportunity and exposure to several different means of looking at energy. So the question asks us, would energy transfer could happen or could not happen?
No.
Okay, so who's got an idea about that? Raise your hand. All right, what about you, Jascarion?
I put the answer in because it said the rock is dropped from the top of the bridge, and I don't understand how it can increase in speed if it's falling from the bridge.
If it's falling from the what? Okay, so if I don't want to put myself up there. If I had a book, it was on the edge of the bridge and I shoved it off, what would happen? It would increase in speed. So we're not there. What are you saying, Jose?
I said it was B because
You said it was what? I'm sorry?
I said it was B because
Okay.
if we drop a ball from the roof, it'll go high up the first time, but then it'll start to lose more energy the more it bounces.
As it bounces, okay. Brandon, did you want to add anything?
Nope.
Okay. How many people chose A? Just raise your hand if you did, that's fine. How many people chose B? C? D? Okay, so got a few stragglers. I understand what you're saying, but that's basically just saying the potential energy and the gravitational potential energy when it falls is gonna soar, okay? You guys right, it's B. It is gonna reduce momentum as it continues on. These are the standards. Here, roller coaster and solar, you're collecting and analyzing data. So are you energy car. It's very important because we have 3 dimensions in science, right? That we go ahead and know how to approach our questions from all angles and from all disciplines. So today you're going to centers, and this is what I want you to do. I want you to go, as I tell you to go to your center, I want you to go over there and I want you to stand and wait, and once you wait, I want you to be quiet. Because I'm going to come through and do specific safety rules for each area, all right? You do remember our science and annotation guide is posted if you need that. The students all had a piece of text that they had to read and ask questions about. I generally just tell them the questions or maybe something that they would wonder about or help them understand the content better. So you guys have an energy pyramid here, all right? You can use your pen. Over there you see a chart paper. That's for when you get finished. Ecosystems with big ideas. These are the questions that you need to fill out, all right? What questions did you have as you read about ecosystems? Where are you reading about ecosystems at? They took different organisms, and as they tried to build an energy pyramid, and as they tried to build a larger food web, they went off into invasive species. They went off into what would happen if more than one organism was here, and they got into a debate about it.
So what eats the hands?
We gotta put
We gotta put this a bird. It was a bird, yeah.
Some of our ecosystem big ideas are if you take one organism out of the ecosystem, the whole ecosystem will be affected. Energy is transferred throughout the trophic levels, and the organisms in the ecosystem depend on each other.
Over in the solar center, we have a solar pad, and I have set up adapters for electronics. Then they also powered my phone and some other electronics over there just to see that when it was plugged in, it was a useful source of energy because they could see the charge buttons hit. What is the purpose of solar panels? What questions have you got about it? You can write that on the article on here, it doesn't matter. How are solar panels powered? Explain the path of energy. And you're going to examine all the things before you do that, all right? They had a radio, a solar-powered radio, and they had to figure out how to set it to a fan, but they also came up with the conclusion I wanted them to get, which is that it was powering the radio back as well. When I look at solar panels, what's that a replacement for? Roller coasters, bring it down, please. What? Electricity. What's the problem with using too much electricity? Okay, so do humans have choices as far as alternative sources? Okay, so solar is an alternative to electricity. Does anybody remember any others? Instead of coal, biofuels, right? What else? Hydropower. And they use that as a form of electricity as well to power things, right? All right, so I want you guys to work on your passage, your questions, and to get some big ideas down for me, okay? In the roller coaster, they're set up on physics stands so that they can manipulate them up and down. They're looking at the interchange of potential and kinetic energy and coming to the understanding, of course, that they exist both at the same time, just in different amounts. The higher the potential, the lower the kinetic, and vice versa. Explain the path of energy a roller coaster takes and what happens scientifically as that's happening. All right, what's going on? And you should have chart paper right here, and use that pen to put it on there, okay? You have everything you need.
So I have a question. Do you still want us to take it off and put it up higher?
Yeah, you're welcome. I mean, you tell me. Is it going to make a difference how high it is about how fast it goes?
The higher up the roller coaster is, the more potential energy it'll have.
Okay, what else?
The more mass equals the more kinetic energy.
Okay, more mass. Is it just more mass? And the speed. Thank you. You might want to add that to that chart. What else?
Energy flows from potential to kinetic energy.
Okay, like, what do you mean? It flows back? Like, explain.
It flows from
Everyone's
potential
listening.
when it goes up high. It builds the potential energy. Then when it goes down, it builds more kinetic energy. Then it goes back to potential.
But are both happening at the same time?
Yeah.
Yes, they are. One's greater than the other. That's right. Okay, I knew what you meant. So here, you have a computer in front of you, right? You have an article about mass and speed. You also have an article about acceleration. So on the back of your cheat challenge, anybody's in the group, I want you to write down questions that you have as you read this together, okay? You are reading for key points about what's going on with that car. Then you will do several trials, 5 trials at the most, all right? And I want you to record the speed on each. They noticed just through trial and error when they were collecting their data that the different cars do indeed have different masses. They manipulated it by putting weight and subtracting weight from it, and by moving it up and down on the physics stand.
Mass plus height affects speed. Inertial mass determined by how much the object resists acceleration. Gravitational mass is a measurement of how much gravity
an object exerts. Weight is different from mass, and mass will never change, but weight will change.
Mass is different from volume. That's what we wrote so far.
If there's one thing I guess I want them to walk away with, it is just a general understanding of energy and how it works in our world, how they see it in their daily lives. And I want them to understand how energy is drawn, how it transforms, how it moves through systems.